Hi, I'm Pauline, and I decided to choose touchdesigner as a medium to explore generative and interactive visuals. In the following devlog series, I create a digital cat's cradle, audio reactive visuals, dreamy film effects, hand tracking visuals, a falling sand simulator, edge blob tracking, facial tracking effects, and projection mapping. As for my references, I was particularly inspired by the OK Go music video, which features a procedural motion capture character. Another reference is OPN's Tranquilizer Visualizer. I just love the retro video game aesthetics and the culture behind live music and their visuals. They depict digital chaos and emotional overload very well. So I started with the intro tutorial building visuals using tops or texture operators used for 2D image processing, and animating them with chops or channel operators used to process numerical data for animation. Using circles and constants to create base shapes, then a ramp top to design gradients and color schemes. The composite top allowed me to layer images using blend modes, transform top to scale and rotate shapes, and the use of noise top and displace top, I was able to introduce some distortion into the image. For animation, I used LFO and pattern chops to generate time-based instructions, and null chop to end and organize outputs. In this devlog, I go over how I built a falling sand simulator where every pixel behaves like a grain of sand. The system runs in a feedback loop between sand T0 and sand T1. A math and limit top creates a simple mask of where grains exist. Then transform tops shift that mask one pixel to check below and diagonally. With composite tops, each grain decides whether to fall, slide, or stay, forming natural piles and slopes of sand. When I click, a panel chop samples color from a movie file in top and stamps it into the sand, kind of like the stamp tool in Photoshop. Each click adds more correctly colored grains. They collide and settle with each other, slowly rebuilding the image through motion and accumulation rather than revealing it instantly. For the next devlog, I built an audio reactive scene in touchdesigner by turning sound amplitude into data to translate 3D boxes. First, I imported a music track by OPN called World Outside. The audio is analyzed with an audio spectrum chop, which splits the sound into frequency bands. With select chop, it selects the amplitude band, which controls the scale of the boxes. So the louder moments in the song make the boxes grow, while quieter moments shrink them. To animate the boxes' movement, an analyze chop and speed chop are used, which analyzes the audio's energy over time to affect movement. So if there are certain bursts or punchiness in the song, the movement increases. If it is quiet or soft, the movement slows down. It is then referenced into the noise transform Z parameter used to create a more natural looking movement. Finally, the scene is rendered and stylized with bloom, blur, color adjustments, and tile effect. In the next devlog, I wanted to create hand tracking visuals in TD, so I built a digital cat's cradle, a web between your hands. For this exercise, I used a plugin called mediapipe, which uses AI-driven real-time computer vision to generate data. The plugin uses the webcam to detect around 20 landmarks per hand, wrist, finger joints, and fingertips. Next, select chops, collect those coordinates, and shuffle chops, reorganize them into TX, TY, and TZ channels, which represents the 3D position of each hand point. A proximity pop checks the distance between all points and automatically draws lines between points that are close enough. In the next devlog, I do a deeper dive into hand tracking to create interactive video transitions. I started by importing 2 video clips as assets, which became the visual sources that the interaction controls and transitions between. Using the mediapipe plugin, again, I used a reusable clamp math to convert hand data like pinch distance into clean 0 to 1 ranges. Next, I am building a hand tracking UI overlay in touchdesigner by visualizing key landmarks like thumb tip and index fingertip. Using aligned SOP and UI text labels, it draws connections between track points, displaying live values which are composited over the video. In the final stage, I experimented with audio-visual transitions. The audio is cross-faded between tracks and shaped with a low-pass filter, so one hand's distance controls how much of the high frequencies are filtered. In the next devlog, I explored live hand tracking visuals to build an interactive piece of generative architecture.
Using a brick to crush an aluminum can.
Building on the earlier hand tracking setup, I kept the existing gesture and audio framework and developed a dithered block environment. I set up a PBR render pipeline with a camera, cone lights with soft shadows, an environment light, and a box geometry with a concrete base color and normal map to give the surfaces more depth. Using geometry instancing, instead of manually placing many cubes, a single box is duplicated using positional data. First, SOP points define where blocks should appear in 3D space. These positions are then converted into top texture where the RGB channels store XYZ coordinates. This top is fed into the geometry comp, allowing each pixel to place a cube at its stored position. A noise operator adds motion, and a rotation trigger cycles between three block layouts, all while moving lights animate the shadows. The system becomes generative because these inputs continuously change the structure over time. Finally, a dithering shader is added to stylize the render.
There it is. Okay, now it's so this controls the block and then this is like the volume.
In this devlog, I will explore projection mapping onto physical objects. I tried projecting onto an opaque lamp, glass face, and an upwards projection onto the ceiling HVAC system in our studio. I learned the projection mapping workflow in touchdesigner, finding it quite simple, and using the Cantam mapper component. I first set up a separate projector display, then connected an out top. Inside the Cantam mapper, I drew custom shapes directly over the projected surface. Once the shapes were defined, any visual can be dropped into them as a texture. For my case, I used the noise top animated with ABS time.seconds. When I projected onto glass, it was interesting how the projection passes through it and gets projected onto the wall, resembling a bit like water and how it refracts light. I then set up the same projection workflow to test an upward ceiling projection in studio. For this devlog, I explored how to turn video motion into generative visuals in touchdesigner with edge and block tracking. The process begins with a movie file in top, where the footage is slightly softened using a blur top so the image becomes easier to analyze. The video is then converted to grayscale using monochrome. The threshold top isolates the brightest edges of each frame. The edge data then becomes input for a script top. The three scripts I took from the YouTube tutorial. One draws typographic particles, the second places sharper letters along detected edges, and the third connects sampled points with colored line trails that visualize motion across frames. These three layers are combined using composite top, and final tonal adjustments are made with monochrome and level top, similar to Photoshop. The result is a generative system where text and lines react directly to the movement and light within the video. In this devlog, I experimented with creating a dreamlike video filter in touchdesigner by layering and blending multiple video sources. Here are the following assets I had used from various videos on my phone. The process starts with several movie file in tops, each adjusted using transform and emboss tops to shift position and add texture detail. These layers are blended together using composite tops, with different operations creating variations and contrast between the clips. To make the visuals more dynamic, cross-tops and switch tops are controlled by LFO chops, automatically cycling between different videos over time. Additional nodes like blur, level, and HSV adjust to soften and adjust color balance. Displaced tops were used to add fluid distortion. By stacking 9 videos, the final result becomes a flowing, surreal visual composition. In touchdesigner, you can video edit real-time and procedurally, as opposed to editing on a timeline in Premiere or After Effects. It can also update and respond to live inputs, like audio, face, and hand tracking, etc. In this final devlog, I explore face tracking in touchdesigner, using the face track chop to control visuals with head movement. A video device in top feeds webcam footage into the face track chop, and filter, select, and math chops convert the data into simple TX, TY, and TZ values representing head horizontal movement, vertical movement, and distance from the camera. These values are then mapped to different visual systems. In a 2D setup, a circle top acts like a flashlight, revealing parts of an image, while a transform top creates subtle parallax effects as the head moves. Next, this 2D tunnel effect is created using a feedback top, while a transform top slightly shifts each frame, creating the illusion of an infinite tunnel. The TX and TY values from the face track chop are referenced to the transform's X and Y movement, so the tunnel shifts as the viewer moves their head. Finally, the same data from head location is referenced to a 3D camera in a render network, including camera, lights, PBR material, letting the viewer explore objects and grids in 3D space simply by moving their head. Skills continued. For design, I began focusing on the Lithium Institute site, where I explore the implications of lithium extraction and consumerism through a spa-like experience. 1 part film, 1 part physical experience to be built. I began modeling how I envision the Lithium Institute in Rhino, though I anticipate using a combination of Blender and Unreal to animate and render, particularly Unreal for the large-scale natural environment scenes set in the Atacama salt flats in Chile. I'm considering having flamingo characters in the film, which are native species to the salt flats, which I plan to model in Blender. As a part of the experience, I want to create a physical cell where one can view the projection while laying down or peering into a cabinet. This is very much inspired by James Turrell Perceptual Cell Project series, where he re-envisions an MRI treatment as an immersive light experience. I plan to continue exploring facial tracking to create parallax effects. The next layer will be to develop tracking to include blinks and eye movements that can activate visuals. I think it will be partially interactive and partially just a viewing experience, where I play the dreamy film effects and edge tracking videos for a different viewing experience. I want to experiment with possibly incorporating a mirror element, and I think DMX lighting is something I will need to explore as well.
What